2.5, there is a sketch. Okay, so there is a diagram there that we have. Okay, so there it is. So what do we see there? So in the diagram, we do see that it is depicting rural and urban climates. Okay, so this is your urban climate topic. We do see that, okay, we have temperature. Those are iso heights, by the way. Iso heights are basically lines that are joining areas um, of the same temperature. Okay, so moving in from outward, okay, if you have 8 degrees Celsius, 10 degrees are moving inwards, uh, 12 degrees, then to 14 degrees Celsius. So as you can see that we have we have an equal increments of 2 degrees Celsius. Okay, so it's basically a gradual increase. Okay, so let's look at 1.2.5. Okay, so looking at 1.2.5, we have 4 graphs here: A, B, C, and D. So the question is, which graph below represents a change in the temperature from rural areas to urban area? Okay, so which one is it? Is it A? Okay, so A, as you can see, it basically depicts that the temperature decreases actually from rural areas to urban areas, meaning which it is implying that urban areas have lower temperatures than rural areas, which is a lie. So that is incorrect. B, okay, so B does depict an increase from rural areas to urban areas, and that increase, as you can see, it's gradual actually. So B is on the good side actually. So because it is like increasing gradually, like with like 2 degrees Celsius increments, you cannot have a graph that is exponential, that is like showing a big increase, okay, or a huge increase. So it is increasing gradually or uniformly. So it has to be B. Let's look at other options though. C, C is constant. Okay, so C is constant. So this basically means that um, the rural areas and the urban areas have actually the same temperature, which is incorrect. And then D, so as you can see, D is quite complex. Shows that there's an increase, then there's a decrease, then there's an increase, then there's a decrease. So we don't see that, we only see an increase. So our answer has to be B. So it is B. 1.2.5 is B. My camera just went blurry, guys. I just hope you guys do see this. Okay. So let's go to 1.2.6 then. The reason for the change in temperature, okay, answer to question 1.2.5, so the above answer, is due to dash surfaces and stormwater systems. Okay, so your stormwater systems, like your drains, that drain water when it is raining so that you prevent flooding. So of course you find those in urban areas. Okay, so you have 4 Roman figures. The first one is natural, second one is artificial, and then the third one is more, fourth one is less. Okay, which pair are we going with here? So we know that the urban areas and the reason why they have a higher temperatures, that is due to artificial surfaces that are made by people, your tar, so on and so on. Okay, so it's artificial surfaces, your glasses, yeah, so it's those materials that are that we put there to basically create the physical development of urban areas. And then also more stormwater systems. There's more stormwater systems there. Remember, stormwater systems, what they do is that they actually like drain water, okay, and basically this prevents surface water from actually being exposed. Okay, and because you do not have surface water, you cannot cool down the city. Okay, remember, surface water is there so that it evaporates. Evaporation cools down the city. Okay, it's the same as let me rather say water vapor. Okay, cools down the city as well. So for an example, like your transpiration as well, that cools down the city by releasing plants releasing water, or losing water in terms in the form of water vapor, in the form of gas. So we are going with artificial and more. So that has to be 2, Roman figure 2 and Roman figure 3. So that has to be C. Okay. So that has to be C. So 1.2.6 is C. Okay, that's C. And then 1.2.7, the wind direction from rural areas to the urban area is influenced by dash temperatures and dash air pressure in urban areas. Okay, what do we have in urban areas? These are like basic characteristics of urban areas. What temperatures do we have? Do we have warmer temperatures or cooler temperatures? Yes, of course, we have warmer temperatures. And because you have warmer temperatures, air, as I said, rises up, guys. Warm air rises up and it leaves an area of low pressure because it is not pressing against the ground. So it has to be warmer temperatures and lower air pressure. So it is Roman figure 1 and Roman figure 4. That pair you will find at option B. Yes. So 1.2.7 has to be B. Okay, and then 1.2.8. Okay, so 1.2.8 says the urban area will experience dash cloud cover with a or n dash in precipitation than the rural area. Okay, again, it's the characteristics, guys. And this is urban climate. Okay, so of course the urban area will experience more cloud cover because it has more hygroscopic nuclei. More hygroscopic nuclei is basically nuclei basically act as a surface on which the warm moist air will be in contact and of course form or rather promote condensation to occur, form clouds, and then of course that's how you have a higher cloud cover. Think about your kettle at home. Okay, maybe if you have a kettle and then maybe you have a surface, okay, or maybe a roof or a ceiling. When that warm moist air coming from the kettle, when it reaches, okay, it does not turn into liquid when it is rising up, but it only does so when it is in contact, when it gets in contact with the surface, with the ceiling. Okay, and then it becomes droplets. Okay, so condensation has occurred. So this is the same. That surface, that hygroscopic nuclei act as this surface, so it basically promotes condensation. Okay, so you'd see that because there's a lot of hygroscopic nuclei which are produced via pollution, and we see a lot of pollution in urban areas, and so it will experience more cloud cover, and also of course with an increase in precipitation. Okay, so it's more and increase, so that means it is A. So 1.2.8, that is A. Okay, right, so let's move on, guys. Let's move on. So we have an infographic below on mid-latitude cyclones. Okay, so this is 1.3 now. We are doing 1.3. My phone is so blurry. Let me try to fix this. Okay, I think that has improved, and I hope you guys do see it well. Right, so and I apologize for that. Truly do. Let's look at this infographic. Let's read a bit. So you have basically 4 pieces of information you have here. We have an article, piece of article on the top left. So it says, warning of severe weather conditions over Western Cape. A well-developed cold front. Okay, so a well-developed, you have to underline, a well-developed cold front of a mid-latitude cyclone reached the Western Cape on Thursday morning. It brought a rainfall which spread to the southwestern parts of the Western Cape. That is Cape Town, Cape Agulhas, and reached the southeastern parts late afternoon. Okay, all right. The bulk of the rain fell over the southeastern parts, okay, which is Mossel Bay and Knysna. Southwestern parts of the south coast from the afternoon into Friday morning, where rainfall increased over 36 hours. Okay, all right, okay. So it's very important to underline, guys, when you are reading these. Okay, and then on the right of this, you have a map showing the affected area. So it's basically the southern parts of the Western Cape, okay, going from the west to east. And then on the bottom left, you have a graph showing average rainfall. So so the rain actually increased, okay. So the Mossel Bay and Knysna were the ones that are affected the most, the ones on the eastern parts. And then on the bottom right, you have a cross section of a cold front, right? Okay. 1.3.1. Okay. 1.3.1 says mid-latitude cyclone mentioned. The mid-latitude cyclone mentioned in the extract is in the initial or mature stage. Well, it has to be in the mature stage, guys, because, well, it was the first words. So a well-developed. So if it is well-developed, it has to be mature. Okay. So so we're going with mature. Okay. So we're going with mature. So 1.3.1, it is mature. Okay. Then 1.3.2. Sorry about that, the lighting. Okay. So 1.3.2, give a reason for your answer. Okay. So you can just quote there, a well-developed. Okay, a well-developed cold front. So at which stage do you have a well-developed cold front? It is only in the mature stage. Okay. Okay, 1.3.3 says, why did the rainfall mentioned in the extract spread from Cape Town to Mossel Bay and Knysna? Okay, so why did that happen, guys? It spread from Cape Town and it went all over to Mossel Bay and Knysna. So those are further east. Okay. And the clue is here, guys. Yes, there we go. The clue is the direction of movement. Okay, it's the direction of movement. This is 2 marks. It's nothing much. It's the direction of movement. The front, the mid-latitude cyclone, of course, we know that it moves from west to east, and so hence Mossel Bay and Knysna were affected. Okay, so basically say this is because mid-latitude cyclones move move from west to east. Okay, so we know that Mossel Bay and Knysna are on the east, so they were affected due to the movement and Knysna. Okay, there we go. So it's basically the direction. Okay, so some questions, like they are a bit they seem like they are quite difficult to answer, but it's actually, you have all of the weapons, guys. Okay, you are equipped, don't worry. 1.3.4, what do we have? 1.3.4, Refer to the graph and determine the lowest and highest rainfall in millimeters recorded in the Western Cape over 36 hours. Okay, so of course, there we go. We have a graph showing average rainfall and it's in millimeters. So of course, the lowest was in Cape Town, lowest, and it was 15 millimeters. Okay, very important that you write down these SI units. And then of course the highest was in Neisner, which was 14. Yeah, that is 40 millimeters. Okay, so there we go. That's the highest and lowest. Yeah, you just take that from the graph. Okay, so let's then move on to another question. With reference to the cross-section, explain how a well-developed cold front results in heavy rainfall over the Western Cape. Okay, how a well-developed cold front results in heavy rainfall. Okay, all right. So now you have a cold front. Okay, a cold front. So we can start by saying that because, okay, or due to the fact that I know how I write is a bit strange, but that's how I usually write. I really write from like the heart, I guess. So due to the fact that the cold front, okay, is associated with a steep pressure gradient. Okay, I said this steep shape that you see, of course, in the cross section, this tells you about the pressure gradient, that it is steep. Okay, so due to this steep pressure gradient, warm air in front of the cold front rises up rapidly, meaning which rises up very fast. Okay, and building, so this results in building tall clouds. Okay, in this case, those are cumulonimbus clouds, which are associated, which produce, or rather, let me say, which produce heavy rainfall. Okay, so there we go. So that's your full marks, guys. Okay, we're looking for these concepts. Do you really understand? Now, this as this cold front approaches, warm air rises up very fast, like very quickly, and as it rises up, that means that a lot of air is going to rise up, and so that means you're going to build tall clouds, guys, which are your cumulonimbus clouds, and we know cumulonimbus clouds are always associated with heavy rainfall. Okay, let me know what you did, what you wrote. So question 1.3.6, how will the heavy rainfall negatively affect the physical or natural environment in and around the Western Cape? So of course, heavy rainfalls flood rivers, which in turn, heavy rainfall causes flood. Oh man. So causes floods, I'm sorry about that, which in turn removes the topsoil, causing soil erosion. Okay, And heavy rainfalls destabilizes mountains, which results in, of course, mass movements. Mass movements are for an example, in Chapman's Peak, rock falls. Okay, of course that it. So rock falls like in Chapman's Peak, which is actually in Western Cape. So talk about mass movement. You can talk about soil erosion. Let me know what you guys did right. So remember, it has to be natural. It has to be physical environment. Okay, so let's move on, guys. Let's move on. There's no time to waste. We have a lot to cover. So this is going to be our 1.4. So this is, of course, as we can see, and it is tropical cyclone. So 1.4.1. Okay, so we have a satellite image of a tropical cyclone in the mature stage, right? Okay, so that's why we have the I then, so on and so on. Excuse me. State one condition required for the development of the tropical cyclone. There's a lot of conditions, guys. There's a lot. There's a lot you can pick from. You cannot miss this one. So of course, I'm sure others said warm oceans, like it has to be warmer than 26 degrees. Others said surface convergence and surface upper divergence. Others said moist air. Others said Coriolis force. Others said it has to be between 5 and 25. So there's a lot, guys. There's a lot. I cannot write all of them. Okay. So that is your 1 mark. 1.4.2. In which hemisphere did this cyclone develop? How do we see that? We look at the rotation of air. Okay. So looking at this satellite image, what's the rotation of air? Is it clockwise or anti-clockwise? If it is clockwise, then we would know it is in the southern hemisphere. If it is anti-clockwise, then of course it is in the northern hemisphere. Okay, so I see these spirals, and these spirals are moving clockwise. Okay, this has to be in the southern hemisphere. Okay, southern hemisphere, because actually, okay, so that's 1 mark. 1.4.3, give a reason for your answer. So of course, because air circulation or rotation is clockwise. That's our reason there. Okay, so refer to A and B on the satellite. So we have A and B. A, what is A? A is our eye. B is so 1.4.4. So B, of course, is the eye wall. So 1.4.4 states differentiate between the cloud cover at A and B. At A, no cloud cover. At B, full cloud cover. A low cloud cover, high cloud cover. 1.4.5. Explain why is the difference, okay, at A and at B. Well, at A, we have air sinking at A, which does not result in condensation and hence no clouds. Okay, and then at B, B, we have rising air. Okay, B, because we have of course a low pressure there, so at B we have rising air. Okay, that is your eye wall. Rising air which condenses to form clouds. Okay. 1.4.6, why are the strongest winds found in the forward leading left hand quadrant? Okay, so that's the dangerous semicircle there. Again, if you do watch my TikTok, you should know. So what happens there? How do you explain this? Well, the direction of the tropical cyclone corresponds with the direction or with the circulation, or is in the same direction as the circulation in the tropical cyclone. You are probably like, what? What do you mean? What are you talking about? Well, we're basically saying that the direction of the tropical cyclone and the circulation of air inside the tropical cyclone align. Okay, they align, or basically they are in the same direction. Which add up to a higher wind speed. Okay, so with highest actually. So basically the tropical cyclone is moving, let's say it's moving, yes, it's moving to the west, right? So inside, what do you have? Okay, inside you have clockwise circulation, right? Clockwise circulation. Okay, now let's focus on this region. What's happening here? The tropical cyclone is moving this direction, but the circulation, the air inside is moving that direction, as you can see. So that is, of course, you wouldn't get the strongest winds here, because you have winds that are contrasting, or maybe opposite. Okay, winds that are going in the opposite direction. The direction of the tropical cyclone is in this direction, whereas the direction of the air inside circulating is in the opposite direction. So this creates more softer winds. Okay, rather relatively, guys, it can't be soft because this is a tropical cyclone, but rather let's say lower, relatively lower winds, lower wind speeds here. But let's look at this position now. This is where you have your dangerous semicircle. So in this position, the tropical cyclone, the whole of the tropical cyclone is moving to the east, and the circulation inside is, or the direction of the circulation is east. So you add both of these two, that of course results in the strongest winds that you have in a tropical cyclone. Okay, so that is your forward leading left hand quadrant. Oh, that's that is a complicated word. Let's go to the next question. Okay, so the next question says, so that's 1.4.7, says draw a sketch of a tropical cyclone in its mature stage, okay, as represented on a synoptic weather map. Indicate the following on the sketch: air pressure reading at the center of the tropical cyclone, at least 4 isobars indicating the correct spacing, and then of course symbol to represent the tropical cyclone. So let's start with the symbol. Okay, we know that the eye, we have an eye at the center basically, and it looks like that. So, and also let's draw isobars, so at least 4. So so these have to be close to each other, né? To indicate that this is a steep pressure gradient, and they cannot touch each other. I made a mistake there. So of course you would have drawn it much more carefully than me. So that's 4, right? And what do you think the air pressure will be at the center? So tropical cyclones, we know this, they are intense cyclones, and so the air pressure has to be smaller than 1,000, guys. So can say maybe 950. Okay, can be 900 and something, 950, 940, 930, and 920. Okay, so it's up to you really. I think my isobaric interval is 10. Okay, right, so yeah, should be something like that. I hope I'm correct. Let's head on to the following question then. 1.5. Okay, looks like, yeah, anticyclones. 1.5, 1.5.1. Okay, so refer to the sketches below on Berg winds. So these are on Berg winds. Okay, all right. So we see a diagram. Know that Berg winds are formed from a relationship between the Kalahari and the coastal lows. Okay, and so when they reach, of course, when they descend, they warm up, they get dry, they get hot, and so when they reach the coastal areas, this produces very high temperatures. As you can see, the X, the weather station is 34, and there's no cloud cover at all. It's very hot. Okay, so name the high pressure cell and low pressure cell indicated on the sketch map that leads to the development of Berg winds. Of course, the high pressure, that is your Kalahari high, that is your high pressure Kalahari high, or Kalahari anticyclone, and coastal low. Okay, that is 1.5.1. 1.5.2, which sketch, A or B, represents the formation of Berg winds? They have to be descending, guys. They have to be going down. Okay, they can't be going up. So it cannot be A, it has to be B. Okay, they have to go down the escarpment and get warmer and warmer. So it is B. Okay, because of course Berg winds are formed by winds descending down the escarpment, and warming and drying up due to adiabatic warming. Okay, very important that you have to be full with your response, guys. Adiabatic warming. Okay, I would even add moving towards the coast. Okay, so that I get full marks. I want to ensure. Okay, so explain why cloudless conditions are indicated by the station model. Why don't they rise up, guys? Well, that's the reason why. Is because they are dry. You only form clouds when your air is moist. Okay, it has to have that moist, that water vapor. Okay, water vapor will condense to water. Okay, so because we know that Berg winds are dry, so of course they cannot form clouds. In a paragraph of approximately 8 lines, explain how Berg winds impact negatively on natural vegetation and suggest strategies that can be put in place to limit this negative impact. Okay, so how do they impact negatively? Okay, they form wildfires. Of course, you are not going to write like this. I'm just thinking of time. They result in wildfires, and they result in destruction or damage of property, injure people. So what should we do? And also kill. And so what can be done? Okay, so what can be done is we should, of course, for wildfires, you should wet the soil. Okay, and emergency services should be on standby. Move livestock to higher lying areas or away from the fire. By the way, this also destroys habitats. There's a lot, guys. Habitats. Okay, it said on the natural vegetation show, so there shouldn't be injure people. Sorry about that. Habitat. You can say it disrupts the ecosystem. Disrupts the ecosystem. You could also say that grazing land damaged. Okay. So yes, there's a lot more, and also yes, these still stand correct. Emergency services should be on standby. People should wet the soil. Then also you should, of course, move livestock to higher lying areas. So your 8 marks will come from these, okay? But you have to put them, ensure that you put them in paragraph form, and you should be correct. Everything should be fine. So yeah, guys, let me know what you think I did wrong, what you guys rather did or would have done. Okay, remember, I'm not perfect. I'm also like everyone else, constantly learning as well, okay, through my mistakes. So just let me know in the comments what you guys wrote, what you think you got on this climatology section. I'm going to move on, of course, to the geomorphology section, but that's going to be in a separate video, okay, so just let me know, and I hope you guys really do pass your exams. I hope you really did. Okay.